So welcome to the first episode of Ham Radio Hands-On. We're going to try and do a little demonstration of how to build yourself a USB charger for an Elecraft or any 12-volt radio. This was inspired because of a lot of YouTubers have been looking at the new Icom 705, which is a beautiful radio, but it's $1,200, and so I'm not going to be buying one for the foreseeable future. But a lot of the YouTubers have been commenting about how nice it is to have a radio that can charge with USB. I'm not really sure why that's a big selling point, but it is. Now, there are a lot of other nice features for the 705, like Bluetooth and replaceable battery packs that are completely different. But I thought I would look at this one thing that people have been saying they've wanted as a feature for a long time for QRP radios. So for our little project, you need a case. This is from Serpac. I think it's SERPAC. It was free at a ham fest. When I signed up, I paid my admission. They had a table with a bunch of these on them. And this is a boost converter from Amazon. 4 of these were $8. And they will convert from 2.4 volts in up to about 20 volts out. Now, they are boost converters like this are actually really efficient. They can be upwards of 90% efficient, so you don't lose a ton of power with them. And it has a built-in USB jack, which will be really useful for this project. You also need a 12-volt barrel connector. This was taken off of another power for a laptop or something. I have another one here. Ooh, pine cone. If that one doesn't work good, and that's actually from an Asus laptop cord. So the first thing we're going to do is take out KX3. And we've got our little Bino battery here. And we're just going to put it into display the power supply voltage. I'm going to put that in right there. And we know center, I already checked, center power is the white one. And so we're just going to tap those in. And we get 14 volts. I don't know if you can see it. You get 14 volts. Which means we know that this connector works fine. So this is basically the project right here. Just put these things together. Now, I do plan on kicking it up a little bit with this $5 voltmeter display, because I'm going to be sending this to somebody. His name is Bob. He has a very popular YouTube channel, K6UDA Radio, and he was one of the inspirations for building a tiny-ish adapter for for USB charging. So one of the other things that we're going to need eventually, or actually real soon now, is a Dremel, because this is about 1 millimeter too big to fit in the case the way I want it to fit, which is where a Dremel will come in. So total cost for this project, assuming you have an extra barrel connector around somewhere, and you probably do if you're anything like any of the hams I know, you don't throw away an old power supply for anything. this works out to about $2. That's the cost of this per unit. You got to buy 4 of them for $8, but you can find a friend to give them to or to sell them to. Everything else is pretty much stuff that you'd find around the house. I will be using a hot glue gun to secure this, and everything else really. It's going to be just full of hot glue. You will need a Dremel, unless of course you use a different enclosure, but I'm going for minimum size. So I'm actually going to turn off the recording and then Dremel and then turn it back on so that you don't have to listen to the whine of the, it's actually not a Dremel, it's a Craftsman, of the rotary tool. But before I do, I'm going to show you a little bit of what I'm going to be doing. So right here, we use this as a pointer. We're just going to shave off about 1 millimeter right off of this edge where the voltage out is. We'll use this. This screw right here controls what the output is set at. So you do need to adjust that before you go live. So you want to have a meter handy to test what your output voltage is so you don't make the magic smoke come out of your radio. So there we go, successfully Dremeled. I don't know if you can see the difference, but I just took off about 1 millimeter from here. There's no circuits right in there. You can see the copper cladding of the board, but I just shaved a little bit off, and that'll get this to just drop right in and fit just about perfectly. So now we're going to take some flush cutters and first we're just going to mark where we want to remove the side wall of the box so that this plug can be accessible. And we take our multi-tool, and there we go. Now, I might have to open that up just a little bit more. Let's see how that looks. And somewhere I brought out a battery pack and a USB. Okay, so we're back. My phone overheated recording video, so I took off the thick, heavy waterproof case, and that'll make it work better. So I did some cutting on the plastic while I waited for my phone to cool, and made that hole nice and large so that the end of the USB cable can actually fit in there nicely in case the USB cable's insulation is just a little bit big. And then I cut a hole on the side there so that we can see that adjustment screw through it in case we want to adjust the voltage once it's all sealed up. So now the next step is to do a little bit of soldering. We're going to put the power cable on, and we're going to put this little voltmeter on. These actually work pretty good, and so to get this to work right, we will have to do a little more cutting on the enclosure to get it to fit. So we're actually going to pop these wings off here and then cut the enclosure a little bit so that has a window to peek through. So I'm going to do that now. So on one side I went a little more gentle because it has a chip right next to it than I did on the other. And we're going to put this all the way down in one side so that we can let that power cable, this power cable, go out this way. So I'm going to hit pause and change my bit on my Dremel to a cutting bit, and be right back. So here we are, and there you go. You can maybe you can get a copy of the name there, SERPAC. These are actually really nice cases. Don't cut yourself. So this is just the first pass. We're going to see how well this looks. And that looks like, well, we got almost 2 digits. So now we know how big to cut. And there we go. And that actually doesn't look completely horrible for lovingly handmade. So here we are. We're getting the soldering iron up to speed. Let it get warm up a little bit. And there we go. We'll let that cool for a second, and then we're going to check it. Because I'm doing this about 3 feet, my eyeball's about 3 feet further away from it than I normally would. I have to see how it goes. Alright, that actually worked pretty well. I'm going to give the backside a little heat, get a little solder through. And then we're going to do the same thing with the positives. And that one actually went pretty well. But now, all it is fitting everything together. So a lot of this is set up. So now I'm going to just take the little voltmeter, drop on some magical hot glue. And we're going to drop that into position. Little battery pack here. We're going to plug the thing in, and I had adjusted it so that it was about set for about 13.5 volts. 13.8 is what you would be charging a KX3 with, or running a lot of radios on, so I wanted it to be about there. Pretty green, huh? 13.4, which is right about where I set it. Everything's reasonably secured here. I'm going to fold up this cable. Making sure that we don't have it in the way of the, let's put it over here. We don't want it to be in the way of the screw for the enclosure. And there we go. We're getting 13.4 out. Now, next thing we do, just to make sure, DC volts, we take our multimeter, 13.42. That looks pretty good. So we know now that the voltage is right and that it's wired correctly. So I'm going to take my KX3, turn it on, and get it in frame. I got the power supply voltage displayed right there. And we're going to take this and we put it in. So I had to switch to a more strong battery bank. This little one didn't put out enough power to keep the thing running. So now we go into the display, battery charge, turn the battery charging on. turn it off. And now we can see this is just a battery bank from Talent Cell. These are great. And we are charging 13.4 volts going in, and it's charging the battery from the Elecraft. No other wires. Get it all in frame, so you can see. Off of USB, and we'll unplug it. It says complains about the power supply is too low. There we go. And if we turn it back on, we can see that it believes the voltage is 13.2 volts. And if that voltage wasn't good for us, I'm going to unplug it before I do this. We can take a little tiny screwdriver here, and we see we're outputting 13.4, and we can change that to whatever we need it to be. So if you were charging up a model RC cars and you only needed 9 volts, well, there you go, you can do that. But ham radio guys like about there. So this is a nice simple project. It took me maybe a half an hour to build. It'd have been less time if I hadn't been trying to YouTube it too. So there we go, one successful project. Next time I'm going to try and show you how to build your very own portable whip for a Wolf River coil. Thank you very much.